In this tutorial, we're going to take a look at the divisibility rule for 7. And it's quite a different rule than the divisibility rules for other numbers like 2, 3, 4, 5, 6. So the procedure goes like this. So we remove the last digit number, the ones digit, and you double it. And you subtract that doubled number from the remaining digits. And I'll go through several examples here and look at is the result 0 or a multiple of 7. Actually, 0 is a multiple of 7. Okay, so in case you didn't realize, that's why it's sort of written that way. Now, if the answer to that is yes, then the number is divisible by 7. If not, or it's not recognizable, you just continue. You continue the process until you get down to a small enough number, usually a 2-digit number, and if you know it's a multiple of 7 or not. So the first example is 8,456. So we're going to take the 6. It ends in a 6. So we take the 6 and we double that. So 6 times 2 is 12. And you see, so we've removed the 6. So it's 845 that we subtract 12 from. Okay, so once we take the 6 off, we're left with 845. So we go 845 minus 12, which is 833. And 833 is probably too big for most people to look at and say, oh, I know that's multiple of 7, or I know it's not. So you continue the process. So the last digit's a 3, and you double it to get 6. So when we take the 3 off, there's an 83, so 83 left. So we go 83, take away the 6, which is 77, and that's probably small enough for most people to realize that, oh, we get 77. I know that's a multiple of 7 because it's 11 times 7. So since 77 is divisible by 7, it's a multiple of 7, then the number 8,456 is divisible by 7. Okay, so that's what I mean by you continue going. See, we probably didn't realize that 833 was divisible by 7, so you do the process again. So let's take a look at some other examples. In B here, a little smaller number, 963, but probably too big for most people to look at and say, oh, I know that's divisible by 7, or I know it's not. So we take the 3 on the end, and we double it. So after the 3 has been removed, it's 996 left. So we go 96 and subtract the 6 from it, and we get 90. And if you know your times table, you probably know that 90 is not divisible by 7. So that means that 963 is not divisible by 7. Okay, so next one's a much larger number, 45,932. So the last digit is a 2, and so we double that to get 4. And so after we take the 2 off, there's 4,593 left over that we subtract the 4 from, which is 4589. So probably too big to realize it's a multiple of 7 or not. So we take the 9 on the end and we double it, get 18. So again, the 9's gone, so it's 458, which is 458. That's the digits that are left. That we're going to subtract this 18 from. So that's 440. Now 440 is probably still too big for you to look at and say, I know it's multiple of 7 or not. So to make it smaller, we keep repeating the process. So the last digit is a 0. Now I'm going to talk about the 0 in a moment here. 0 doubled, of course, is 0. So 44 minus 0 is still 44. So really, when you get a 0 in the end, you can just drop the 0 and look at the other digits. So 44 certainly is not divisible by 7. It's not a multiple of 7. So that means that the number 45,932 is not divisible by 7. So we had to do the process 3 times here to get small enough to have a number recognizable that isn't divisible by 7. So the next one is 27,104. So the last digit is a 4, so we double that to get 8. So after the 4 is gone, it's 2710 left. So we take 2710 and subtract this 8 from, which is 2702. Probably too big to figure if it's a multiple of 7 or not. So we take the 2 on the end and double it. So we go 270 minus this 4, which is 266. Now, probably still too big to be recognizable as a multiple of 7 or not. So we take the 6 on the end and double it to get 12. So what's after the 6 is gone, there's 26 or 26 left. And we subtract that 12 from it to get 14. Now, 14 is probably small enough to realize that 14 is a multiple of 7. It's 2 times 7. So that means that 2704 is divisible by 7. Now, if you remember the rule from the previous page, There are a few cases where you might get this last number to be 0. So I want to do one of those. Okay, so I chose a number that works out like that. So 105, it's probably a little bit too big for most people to look at and say, I know it's multiple 7 or not. So the last digit on the end is 5. And if we double 5 or multiply 5 by 2, we get 10. So see, the 5's gone, so it's 1 0 that's left here to be subtracted by this 10. So that 1 0 minus this 1 0, 10 minus 10 is 0. And of course, 0 actually is a multiple 7. It's 0 times 7. So that means that 105 would be divisible by 7. And of course, we can check with our calculator. 105 divided by 7. It does work out to 15 evenly. So 7 does go into it evenly. So it's divisible by 7. So that's the divisibility rule for 7. You subtract the last digit doubled from the remaining digits and keep on going until you see a number that's either recognizable as being a multiple 7 or not, to say whether it is divisible by 7 or not. And that's the end of the tutorial.